Good afternoon, everyone. So today the topic at hand is raining CVs on WordPress plugins with Semgrep. So let's talk about it. I'm Sheeraz. I'm a content engineer at Hack the Box.
I'm Shreya Pohekar, product security analyst at HackerOne.
So let's cover the agenda first so that you can attend what you want. Okay. So first of all, we are going to talk about somewhat about Code Vigilant, the project that we did this research under. After that, we'll explain why we chose WordPress as our target when we were doing this research. After that, we'll show our approach, how we approach this target. And after that, there will be a short session on what is Semgrep, how to use it, how to use Semgrep. And after that, we'll show you how we refine these, like how to write basic rules and how we refine these rules to find basically a lot less false positives. After that, we'll cover the automation side of things. So while we were doing all of this, things got super tedious after a while. So we did a lot of automation, and that led to a tool called Accesses Bomb. We'll talk a lot more about it in later sections. And then we'll talk some more about developer misconceptions and best practices. Then we'll show you what are our plans for the future of this research. So let's start with it. The Code Vigilant project basically is a project that came out of with the need of making open source software more secure. So we all know that a large number of users basically use open source software, but a very few of them actually contribute towards securing them. And that is what our aim at Code Vigilant is. So when we are doing some sort of research, our objective is one of two things. The first objective is identifying these vulnerabilities in open source projects and getting them patched and fixed. The second objective is, if we can't do patching, if the developer has abandoned the project and the project has been open for too long, but it is still being used somewhere, then making it public information and basically discourage people from using it. So now Shreya will talk about why we chose WordPress as our target.
Thank you, Sheeraz. Okay, so why we chose WordPress as a target? So the very first reason for this is the Semgrep released the alpha version for the PHP in 2020, and once we knew that a lot of open source CMS projects are there that are really widely used, and WordPress is one of them, and it has got a list of 80,000 plus plugins, and we already knew that was a jackpot, and that's why we chose WordPress as a target. Okay, the pen testing approach. So since this talk is all about static code analysis, so first let's get to the basic definition of what it is. So static code analysis is basically reading through the code in order to find out vulnerable patterns and any vulnerability that you can find just by reading without executing the code. So that's that. So moving on to the next few points, these were the 2 points that were part of our whole research. First is moving from code to feature, and other moving from feature to code. So the first point is very obvious, that Semgrep was giving us all the output. It used to give us the exact code snippet, the corresponding line number, and we used to just install the plugin and used to just validate that. So it was as simple as that. But the catch here is with the next point, which is the feature to code thing. And what it is the thing that we do all the time with bug bounties. So we are simply testing out the web application. Here we were simply testing out a randomly chosen WordPress plugin. So what happened here was, when we were doing such exercise, we came across a lot of patterns for which we never wrote a Semgrep rule. So we started with very basic XSS or SQLi rules, but doing this exercises allowed us to write some more tricky patterns around rules. And yeah, that was the interesting part for this particular exercise. Okay, so since I'm saying a lot this term, Semgrep, so let's see what it is. So in one of the previous talks in the bug bounty craft track, Sandeep had mentioned a lot of tools that are open source, and one for PHP is SAML. So like for this research, we chosen Semgrep. So like I said, there was an alpha version for it. So yeah, it's an open source tool for doing static code analysis, and it does that at great speed. It has got support for 17 plus languages, including Java, PHP, Python, Go. And yes, it allows us to write custom rules, and that can be according to your specific code basis. And yes, it is used for either hunting for vulnerabilities, or you can enforce certain guardrails on your code basis. Okay, so Semgrep usage. So if you are not aware how Semgrep works, so this screenshot is from the Semgrep playground, where on the right side, you see that the highlighted line number 7 and 8 depicts a sure shot XSS, where we are using a variable car, and there's a post-based parameter ASD, and we are simply echoing it. Nothing can be more basic than that. So the left side depicts how a rule can be written in order to catch that particular pattern. So starting from the language, it's PHP of course. Then with the code, which is $v equal to %get key. So here $v can be referred to any variable defined in PHP, and then we are using a $get key, and here key can be any post based or a get based parameter. So like we have done it for get based parameter, there is a or condition for a post based parameter, and we can do it for request based parameter as well. Now the important thing here is the 3 dots. So the 3 dots helped us a lot in identifying whether a code snippet was actually vulnerable or not, because you would see the highlighted scenario in a very rare case, because that generally doesn't happen. So a lot of times there are a lot of operations going on within a variable when it's declared. So there can be a lot of filters being used. So the 3 dots allowed us to just by reading the code, we could identify if the plugin is actually vulnerable or not. So by doing that, we were just simply reading the code, but we didn't used to like install every plugin all the time, because we knew that there is a filter present, means there is no XSS present. So that was that. And then the last line is simply echo $v. So the 3 dots are basically all the lines that would be coming between these 2 defined patterns. Then again, here the important part is writing the exclusions. So like we know that a lot of filters are defined to make code not XSS exploitable. So here are 2 examples just written. If the code is part of int val, then the code is not vulnerable to XSS. That we are like, for example, assuming. So we will be adding all that in our exclusion list. And okay, so that was the UI thing that we just saw, and corresponding to it, a YAML file always gets created on the Semgrep platform that looks just like that, and it's an example from the previous slide, and all the same things are written, like there are pattern either and the pattern defined, and there is a pattern not inside. Means your defined pattern should not be inside filters such as int val. Okay, so here is a small demo which will show you the basic usage of how Semgrep works. So if you can see, I am gonna. Okay, so the first command is just listing out the contents of folder for testing, which we created for testing purpose. It does contain 2 folders, admin and user, and a lot of files which contain the vulnerable code. Now we are gonna have a look at a basic XSS rule and how it looks like. So see, here you can see that a lot of filters have been defined. So we jotted down a list and it contains mostly used filters within WordPress environment. So yeah, and like you see in the pattern either, you see that it's a get key, post key, request key, and the pattern inside is echo $X. So that means that it's simply saying that it's echo $get key. It's as simple as that. So like we see in our previous slide that we were first initializing the variable, and here we are directly calling the get based or post based inside the echo statement. So these small tweakings were really helpful, and those were giving completely different results with valid accesses. Okay, so the Semgrep command that we write here is Semgrep --config, the file that we just saw, the YAML file, and our folder for testing. And it does outputs a few results. And in line number 6, as you can see that it echoes $get k. But in line number 22, you also see echo int $get I, which means, so we had not included int as part of our exclusion list. Hence, that's the result on the screen. And we were using multiple cases as well, where on line number 31, you can see that it's been preceded by ABC and succeeded by XYZ, means whatever lies between the echo statement, your rule should still work. So that was for XSS. I'm going to run a similar sort of thing for SQLi as well. So yeah, that's a basic rule for SQLi, where you can see that WPDB get row is being called and there are no prepared statements used. And that means that it's a direct SQLi on a WordPress plugin. So same thing here also, we need to add all the exclusion list. Now the same command, just the config file changes and the folder for testing. Like you see here in the video, we got a result on line number 5 where it looks like it is a valid SQLi, but it's not actually. So we'll be covering that in upcoming slides, explaining why it was not a valid SQLi. So that was all for this demo. Okay. Thank you. Okay, so like I said, refining the rules was really important here because as I said, that we were moving from feature to code as well. We were looking through a lot of different coding styles, coding patterns, and how different developers are doing different stuff. So based on that, we were doing all our tweaks and tricks, and we were writing just by a small change, we were getting completely different results. And those are some of the examples. Like on the second screenshot, you see that there is a function call for get row. And in the third screenshot, you see there is a call for WPDB query, and both of them are going to give valid SQLi results. Okay. So for this section, so that was the end of Semgrep, and now I'm going to hand over to Sheeraz.
So as Shreya just told us that how we wrote our Semgrep rules. So writing these rules were a bit of an experiment, because initially we were writing some basic rules and then we were running them, validating these plugins manually. And then we ended up with a bunch of plugins that were again hand validated in order to find out that more of these filters are in place that make our pattern basically unexploitable. So that's how we kept on enhancing them. But after a certain point, we came to a point where it was too trivial to keep doing it over and over and over again. And also we were validating these issues. So somewhere around we found 150 plus SQL injection possibilities, and we hand validated all of them. But while doing that, we kind of figured out that doing it by hand was very tedious. So even if you find just one SQL injection, so let's say that there is an SQL injection that works on the administrator panel of WordPress, but you cannot exploit it in an unauthenticated fashion or with the lower user privileges. So now so we had to do this all over again. So let's say we had like 50 plugins that were actually vulnerable out of those 150. We had to do all of this validation again and again and again. So that's why we ended up writing smaller modules. At first, we were writing smaller modules to automate this. The first one is escalation of vulnerability with various different user privileges. So it is somewhat like like you might have used authorize in Burp. And this is exactly what it does. But first of all, it reads the Semgrep files, makes sure that the SQL injection is actually vulnerable, and then it goes through and tests all five or six basically. So WordPress has 6 default privileges: administrator, editor, author, and then I think subscriber, and then unauthenticated. So we tested against all of that using our small module, which led to another problem. So every time you write one of these automation scripts, WordPress is sort of a problem in that sense that WordPress isn't structured. When a plugin developer actually starts writing a plugin, they don't have to follow a convention. They do it however they want to, which means we have a problem here. As let's say that there's one plugin called custom add user or whatever. You install that, and the developer has written it in such a fashion that it is accessible on the admin panel at /admin/customadduser.php. That is a single file, easier to navigate to, easier to find. But that's not always the case, because now there are some developers who were writing code in such a fashion that it was object-oriented code. So the class and the function that we needed to access was in a completely different file. Then it was getting inherited and then used somewhere else completely. Reaching that function manually was so hard that we couldn't really get to them manually. Trying to find any structures led us to believe that there weren't any. So what we ended up doing was, we crawled through, we made a login simulation script, which logged in and crawled through WordPress, a fresh install of WordPress. And then what we did was, we again installed the plugin and then ran the script again. So we have 2 instances now, a fresh install and one with the plugin installed on it. Then we diffed them together to find the unique URLs. And now we had a smaller number, more targeted URLs or access modifiers or whatever. And then you would be able to use your plugin, you would be able to use your payloads on these now. So that was the second automation module that we wrote. And then the third one was report generator. The report generator was, so we ran into a problem. We found 50 something XSS, and for each 50 something SQL injections, I'm sorry. And for each of these, we had to write 2 reports. One that went to WP Scan and one that went to Code Vigilant. The Code Vigilant report had a lot more details, and the WP Scan didn't needed much details other than the exploitable part of the code, and that's about it. So in order to do that, we wrote a third module because we were confusing, and it was very confusing to do it twice each and every time. And yeah, it was time consuming. So that was the third smaller automation. But while doing all of this automation, we kind of got addicted to it, and we wanted to do everything by automation, because validating 150 SQL injections by hand led to a lot of tedious amount of work that we did. So funny story is that I started working on validating about 10 plugins, and I kept on doing it till like 20, and it took me 2 days, including nights, and I didn't sleep. So yeah, it's similar. And Shreya divided the work, so she did it in I don't know, 2 weeks, which is fine if you're doing it for 150 plus plugins only, I guess. But if then we wrote XSS rule, and we ended up finding about 4,000 plus possibilities of XSS. And we kind of gave up on it immediately because it's not easy to do it, right? You can't install each and every plugin, look at the source code, and then go back to it, try to exploit it, see if it's not vulnerable, and all. Doing it all 4,000 times would take, I don't know, years. So we made an XSS bomb. We got to work, and initially we wrote a parser for Semgrep. So the files that Semgrep was generating, we took out all the important information from it. We took out the possible vulnerable parameters, file names, plugin names, and all of that. We made a VM and put that on it, and then let the script run in order to install it all together, validate it, then reset back and work again. We'll see a demo, so it's not that confusing. The second point is, making XSS bomb was super hard. Because here, first of all, there was no guidelines on doing it. We were doing it very manually. And second of all, when we were automating it, there were like 3 failures that we had. We wanted to make them fast because we are doing it in like hours and hours. So the first approach was initially our test bed ran on Vagrant. So we wrote a Vagrant template, which generates a virtual machine that has a blank WordPress. Then we SSH'd into it, and then we installed the plugin, set it up all together, and then we started to fuzz it. But what this added was latency. Each and every time one plugin was validated and we moved to the second one, it took like 2 to 5 minutes, which was not an ideal time we were going for because again, it will take months. Second approach was trying to use containers because, well, that's the logical choice after VMs because they are on the same computer and the same process should work, right? But another problem, we wrote Docker files to generate a config of WordPress that should have all the things that we need. But even then, we were trying, every time the container got destroyed and recreated over and over again, our configuration had to be done over and over again, which led to about like one plugin getting validated to like 2 minutes. Not good. So at last we ended up doing was instead of trying to spawn a new instance altogether, we worked on resetting the WordPress instance instead of trying to recreate it. So we created a base VM and we ran our tools on it, which led to speeds getting like increasingly higher. Like you can, I'll show you a video after this. So let's see. Let's show you the outcome of that. So this is XSS bomb. So right here, what we are doing is, let me pause it. So it takes a WordPress, like username of the WordPress administrator and the password of that WordPress administrator and a URL to that link, which is stated on that same VM. And then it parses through all of these Semgrep files in order to extract various different vulnerable issue. I don't know really. Wait. So right over here, it is trying to fetch all the parameters for a vulnerable plugin, but it is blurred. And I don't think you can see the blurriness of it. So it's the plugin name is given over here, but it is blurred and it is invisible here now because we didn't want it to drop 0 days here. So if you look at this, it is parsing all of these parameters for each and every plugin that we gave in the repo or in the folder. And then after that, it tries and validates all of them automatically. So we use GXS as our validation engine or fuzzer, and other wrappers we wrote ourselves. So here it is testing, let's say, plugin X. It goes there, it installs it, it fuzzes it to a point for very specific fuzzing, which means the only parameters that are fuzzed are the one that we found earlier in the parsing script, which was given by Semgrep. And then it tries to find the SQL XSS exactly where it should be, and gives you a URL you can visit and see that alert pop up. Again, the URL is blurred after that general.php because the name of the plugin was in that link. Let me play it once more. But well, and now that you see, as this goes on, now it has already done it for 2 plugins and it has started validation for the 3rd one. So you can basically see that it solves the speed problem. We don't have to, for this demo, we did it for 10 plugins, and I don't think you want to sit here and see it for the whole 4,000 plus plugins. But the point is that instead of doing it for hours and hours, we made a automation to do it in minutes. It also, whenever it encounters an error, which happens quite often with WordPress, if if a plugin is super old and isn't supported with the latest version anymore, it would crash and it will be inaccessible. In that case, it self-heals and comes back to life, and then keeps on fuzzing next plugins. Moving on, it finds the 3rd XSS in the whole 10 batch of 10, and then I'll show you what it generates afterwards. So it generates a basic JSON file, which would have all the valid XSSs, all validated automatically. Yeah, so coming back to our slides, that was XSS bomb. So I think you saw how it actually works. The speed of the tool is way better than human efficiency for sure. And the language we used was Python for this. The engine that we run for fuzzing is GXSS. And now Shreya will talk about the developer misconceptions.
Thank you, Sheeraz, and hello once again. So I'll be talking about developers' misconception. So here are 3 bullet points that I've added for the same. And the very first one is a bit interesting here. So there was a plugin for which we found reflected XSS, and there was a filter being used, and that was sanitized text field. So what was happening was, the developer did use the plugin, the filter, but he was not aware of the context of where the output is gonna be reflected. So the output, the sync here was the SRC attribute of the image tag. Just a bit theory about what sanitized text field filter does is, whenever you add a double quote, it's gonna escape it with a backslash. So yes, since the filter was in place, the backslash was added by the filter. But since backslash is a valid part of a URL, the SRC tag was still complete, and the quote completed the SRC tag, and we were able to inject on error equal to alert 1 into our payload, and we get a valid XSS trigger. So that was an instance, not just sanitized text field, but there were other instances where filters were used, but the code was still vulnerable to XSS. So that was a leverage that we got because we had the access to the whole source code. We were able to see that how things were going around. So that was a huge plus. So another thing, same thing happened with SQLi. And here again, it's the sanitized text field was used. But what it does is sanitized text field doesn't escapes the single quotes. So because of that, we were able to successfully inject the payload again, and it was a successful SQLi. The third instance is when filters protected against XSS, but it was still vulnerable to SQLi. And the vice versa is also true, where all the prepare statements are used, but no other filter is used to protect against XSS. So means you will be filling out some form using some data, and then that data is going to reflect in some other place. But since there is no filter in place, you are going to get a valid stored XSS there. So those were 3 things that we identified while our analysis.
So as Shreya said, I don't think like developers didn't really knew what they were doing. they had a false sense of safety when they were using sanitized text field and other filters that were easily bypassable. So let's say that they were taking input and then passing it to these functions. And then after that, they are passing it to the database. So we can clearly understand that while they were writing the code, they had this false sense of safety that this particular, they tried to secure and sanitize the input, but they did it all wrong because they thought sanitized text field actually sanitizes it to a point that you can just pass it to the database. But that's not what it does for sure. While doing all the source code analysis and looking at so many of these mistakes, what we could say for sure was when developers tried to actually protect it and were really successful was when they use nested filters. So like some developers actually use sanitized text field and then strip all tags and other HTML escape characters and all of that. When they use that was really handy because first of all the special characters were missed or removed and then encoded, and then it was just a string. So that worked really well for them. In case of XSS what developers also did was output encoding and sanitizing various contexts like URL context and HTML context, etc. Coming to our last point is one thing that we weren't able to bypass during this research was WP magic codes. WP magic codes is it's a feature of WordPress that is there by default and it's turned on by default. So even when we could see that there is a clear shot XSS or SQL injection, whenever we try to input our payloads into it, it automatically adds it creates it into a string. Although like there are actual known bypasses for this, but we weren't able to bypass it. There is something called a GBK encoding in which we saw on the internet that people did bypass it. Although we weren't successful with that and we are still working on it. But yeah, that was something that we thought you should always have it enabled.
So after all the hard work and all the sleepless nights
and blood, sweat and tears, we got, Shreya got her first CV.
And then Sheeraz got his first CV.
Then she got her second.
And he got a straight 20 CVs.
So after all of that, we got like 20 CVs each. So, and after a while, it was like 48 CVs that for us combined together.
Yes.
Which was like an insane number because we started with it with like just one single CV. We started hunting for just one single CV because we wanted that.
Yes, it was like a goal. The first goal was to get a first CV and that feeling was just insanely amazing.
Yeah, so let's talk about the future possibilities that we are working on the research now. And that is, first of all, we are hunting, we are going to come, well, let's see. Sure, we'll talk about this.
No worries. Okay, so like we said that there were 80,000 plugins present and the first focus was to work on WordPress plugins, but we had future possibilities around moving towards WordPress themes or other PHP CMS, or maybe either trying out something with a completely new language that Semgrep supports. Then writing rules for various vulnerabilities because this talk was all about XSS and SQLi because we dig a lot into it. But the whole other lot of vulnerabilities like LFI or SSRF or RCEs, those are still pending and we are on to it. And yeah, hopefully we are going to get some more CVs around these bugs as well.
So like she said, RCEs. So our rules for RCE is ready and we are running them at the moment, like as we speak. And other part is that also we need to improve our automation in itself because right now it's called an XSS bomb because it only searches for XSS. But we wrote it in such a way that it is modular, very modular. So it is soon going to be a vulnerability bomb instead of an XSS bomb, which would be able to validate all of these for us automatically and get us more CVEs. The other and doing more automation where it is possible, because at the moment there are some limitations with XSS bombs that we are trying to figure out. So we are also going to get that done. Hopefully that will lead to a lot more stuff. Thank you.
Thank you so much.
If you have any questions, we are all ears. Yeah. Yeah. So we didn't search for DOM-based XSS basically. What we did was, in our research, what we did was we went for the reflected XSS or the easier vulnerabilities to find at first. And then we wrote our rules in such a way that we were able to find them, like most of them were not false positives. We went for that approach first. No, it was not a single file. So Semgrep has issues with dealing with a lot of files. And what we did was we wrote an SVN wrapper around it. So we were we get pulled all of these WordPress plugins at once. And then before Semgrep breaking in, we wrote a SVN wrapper around it and we ran on a singular directory, a small piece of code.
Yeah, so we didn't worked on rules which were like you are saying, the sync is one file and the source is another file. So we are yet to research on that particular thing. We started with our basics, and yeah, that's where we are right now. Thank you. And one more thing I wanted to cover was like we did show a demo for folder for testing, but actually in in the real case we were running that on 80,000 plugins in a single go. So if you are ever trying that thing, it won't ever work. So it was a script written for that. So we used to iterate through every plugin in order to just so that the Semgrep doesn't breaks, and for every plugin a separate output file was created, and that's how it was very easy for us to determine where exactly to look for when you are working on a plugin. So yeah,
Semgrep doesn't, at least for PHP, that is our experience, that if you give it a huge data set, I don't know if it's just limited to PHP, because I think any tool would break if you give it 80,000 plugin worth of data, which was, I think it was even more than 2 TBs. So,
and it took around 3 days or so to run a single rule.
Yeah, it took a lot of time. So the whole point was we were breaking it down into smaller chunks, or the chunks that Semgrep could handle at a time. And then we were generating output for that, and then moving to the next chunk of these code that we were testing at the moment. Yeah. So these are some references
that we are using.
Yeah. So GXSS is the tool that we use for validation, and then there is we have some open rules that you could find on Code Vigilant's GitHub that might come in handy. We have our profiles on Code Vigilant where you can find more information about us. And then there is Shreya's blog about
the developer's misconception.
Yeah.
The sanitized text field is basically in detail in this very blog. So please go through it. You'll find more about it.
And those are our Twitter. So if you didn't want to ask in front of everybody, you can just shoot us a message on Twitter. Our DMs are open and we'll answer you. Thank you.
Thank you.